Okay, good day and welcome everyone with the beginning of one of two videos, which are the new update for June and July exam preparation for the new CCNA 200-301 exam, the online exam of course of Cisco. My name is Sajjad Ghafouri once again from the III networking channel, and we will start today one of two videos that we will express in those videos a new update of new questions that you might face in the exam, and it will be useful for you maybe to have some technical discussion regarding those questions before you have the experience of the online exam. Anyways, they will be beneficial for you either in your real time, in your real like networking environments and working, or in the online exam that you are planning to take. So the new update of June and July is about a total of 40 questions. So I have divided those 40 questions in two videos. Each one will be 20, starting by question number 1 up to question number 40. So for question number 1, it will be like several new coverage cells are required to improve the Wi-Fi networks of an organization. Okay. Which two standard designs are recommended? The question says that, like, maybe you have this organization that has only one single floor and it has some areas that are covered. It will be in this way. What is required is several new coverage cells. So maybe you'll need to add some more cells, like in here, in this place. Maybe this one is not really working correctly, so you'll need to add this one here, and this one, and maybe this one in the corner, so that will cover the entire area, like in this way, maybe using the Wi-Fi. So we need to choose two recommendations from the design perspective to improve the coverage. Number 1, or A, says that a 5 GHz provides increased network capacity with up to 23 non-overlapping channels. I doubt that, because I believe that the 5 GHz does not give a total of 23 non-overlapping channels. Yes, the 5 GHz does provide non-overlapping channels, but I believe they were like 22 or something. We'll go back to that. B, 5 GHz channel selections requires an autonomous access point. No, this has no idea about the type of the access point. No, it's either the access point supports broadcasting using Wi-Fi 5 GHz or not. That's it. It's not about the mode. Cells that overlap one another are configured to use non-overlapping channels. By the word cells, it means access points. A cell that is broadcasting, the access point itself. So it says that a cells like those three, maybe, that might have overlapping channels between them, can be configured to not have overlapping channels. Yes, because you have channel number 1 starts from this frequency to this one, and channel number 2, 3, 4, and this one, I'm sorry, is 5 and 6. So channel number 6 starts from this point, where channel number 1 ends to this point. So channel number 1 does overlap with channel number 2, 3, 4, and 5, but does not overlap with channel number 6. And you complete the same way, you will know that, or you will notice and find that channel number 11 does not overlap with channel number 6. I will not go deep into that, because chapter 6 is all about this thing that I have already produced in this channel. You can search for that in the playlist. You will find the CCNA 200-301 complete English course, as well as for the Arabic language as well, another different course. Okay, so the idea will be that we can configure this access point or this cell to broadcast by using channel number 1, and this one to broadcast using channel number 6, and this one by broadcast using channel number, or to stream using channel number 11, and thus you will cover this entire area completely with no overlapping. So C is correct, and you can do that by yourself as an engineer. Adjacent cells with overlapping channels use a repeater access points. No, this is not a condition. Okay, and E, hopefully it will be correct, will be for maximum throughput, the controller is configured to dynamically set adjacent access points to the channel. Dynamically to set adjacent access points, so these are adjacent to the channel, to a same channel. Maybe you have access points that are this close, so all of them will stream by using the same channel. Maybe you can do that by using the controller, so it will be using the same VLAN and the same broadcasting. That can be happen. So E is also correct, and that should be enough for question number 1, since it's asking for 2 questions, or I'm sorry, for 2 answers. Okay, question number 2 will be the service password encryption command entered in a router. What is the effect? A, restricts unauthorized users from viewing clear text passwords in the running config. Unauthorized users, well, actually it will restrict everyone. B, prevents network admins from configuring clear text passwords. Nothing will clear someone, like, actually you can configure a clear text password with a hash key and that's it. It will be hashed automatically after you do that. C, protect the VLAN database. No. And D, encrypts the password exchange when a VPN tunnel. No, it's about something local inside the router. Actually, what I believe that will happen is that once you enable this command and you issue show running config, all the clear text passwords will be shown as hash to you. So you will be in a difficult situation if you forgot one of the passwords and you would like to show running config to see what was that password set for. So you will find that, oh, right now it's hashed because of that command. So even you, the administrator that did configure that command previously, you will also see that the password right now is hashed, so you lose it. So I will go with A for now, because it is meant to restrict, I'm sorry, I'm losing some of the language. This command is meant to restrict unauthorized users from viewing clear text password by hashing it in the running config, but even you will be a restricted user, sorry, an unauthorized user, because it was meant to unauthorized people, but even you, when you show run, you will see that as hashed. So I will go with A for this question, because B is not logical for me. C and D is definitely incorrect, but B is not logical for me. Okay, question 3 will be, which type of an IPv6 address is publicly routable, just like an IPv4 public? Multicast, no, it's inside of a company, it's one-to-many. Unique local is local. Link local is local. No, no, and no. Global is something global. So this question is about some English skills rather than some technical skills in the exam. Question 4 will be, which 2 statements are true about the command static IP route this subnet with this mask by using this next hop? Okay, let's establish a static route to 172.16.3.0. Yes, that is correct. Let's establish a static route to .2.0. No, .2. Something is the next hop, not the destination. It configures the router to send any traffic for an unknown destination to this network. No, this is not a static default route. This is a static regular route. So not any unknown will be sent to this destination. No. And rather it should be sent to a next hop. So this entire command is incorrect. It configures the router to send any traffic of unknown destination out of this destination. No, this is not a default route. It uses the default administrative distance. Well, since there is no numeric value defined in the end, so yes, it will be using the ID. It will use the ID of 1, which is the default. So E is correct. F, it's a route that would be used last if other routes of the same destination exists. No, because static route has an AD of 1. After that I have EIGRP with 90. Sorry, OSPF 110, ISIS 115, RIP 1020, BGP internally will be 200. So no, static route will always be the #1 preferred route, even if other ton of routes are there and competing it. Static route will win always, so it will not be the last one. So the answers here will be A and E. Question 5. Which 3 statements are typical characteristics of VLAN arrangements? Okay. A new switch has no VLANs configured. Yes, Cisco switches has no VLANs configured, because VLAN A is a default VLAN by default, and the bit tokens as well, so they are not configured. Connectivity between VLANs requires a layer 3 device. You have seen that. Just in case you have finished my entire course, then you would be very sure and certain that there is no way that multiple VLANs communicate between themselves without a layer 3 device, either a router with a router on a stick protocol or a multi-layer switch with SVI, switch virtual interface protocol enabled or method. VLANs typically decreases the number of collision domains. No, they create virtual broadcast domains, but inside each virtual broadcast domain there is multiple collision domains. And no, each VLAN uses a separate address space. You can definitely do that. A switch maintains a separate bridging table for each VLAN. Maybe. VLANs cannot span multiple switches. No, they definitely can. So I have A, B, D, and possibly E. Which one will I go with? A switch maintains a separate bridging table for each VLAN. This one is also correct, I believe. We should have a lab like right now. If I can enable a lab right now, then it would be better, but I believe that this also is correct. So I have four answers that might be correct for me, but I have only to choose three. So which three will they be? B and D, I will not negotiate. B and D, they are definitely correct, but A and E. Okay, so when you establish a new Cisco switch, you will find VLAN 1 is in the routing in the VLAN table, and you will find 102 or 3, 1004 and 1005 are there, and they are reversed. You cannot change them. So are they configured? Maybe. Yeah, we can assume that in Cisco switches, yes, we can assume that those are configured, maybe for the sake of this questions. So I will go with B, D, and E for question number 5. Unless you have a different opinion, then tell me please. Okay, question 6 says, to which device does R1 send packets that are destined to this destination? Let's see, how does the routing table knows or can reach this destination of 10.10.3.165? Okay, so 10.10.13, I'm sorry, .0/25. This one ends with 127, so 165 is not there. Starts with 128/28, means the increment value is 16, so 128 plus 16 will be about 144, so 165 is not supported. 144/28, no, I'm sorry, 1 minute /28. Yeah, /28 has the increment value of 16. That is correct. 144 with an increment value of 16 would end with 160. So no, 165 is not included. 160 but /29 means that the increment value is 8. So this one ends with 167. And 165 is included, so yes, this one is good. Maybe there is another choice. 208 is not there, it's far beyond that, and no need for a static default route because it's there already. So this one wins, and this one's next hop is Gigabit Ethernet 01, which has the IP address of 10.10.10.5. Okay, so which router of those is the next hop? Actually, the naming of the interfaces is not showing here, so I'll have to choose by using the IP address. So 10.10.10.5 will definitely be here because this is the network of 10.10.10.4/30. So this will be like .5, this one, and .6 here. So this will be my next hop, .5. So I will choose R3B. Okay, for this question. I hope that this was clear for you. Please erase. Yes, thank you. Question number 7 says, I hope that the text is also clear for you. Which two commands are used to create a port channel 10? Okay, so port channel 10 is a layer 2 and up by using LACP and including two interfaces. So that would be good. I will need to either make those ports as either active or passive to, I'm sorry, to take a role in the LACP negotiation process. So interface range gigabit Ethernet 00 and 01, that is correct. Channel group 10 mode active, yes, this one is possible. Interface gigabit Ethernet 00 and 01 mode desirable, no, this will be PACP, not LACP. The same interfaces mode passive is also possible. The same again as auto, this will be PACP, and the final also the same again as on, so this will make them non-negotiable. This will force them to become up, so they will not use LACP, so this one is also incorrect. So either by setting those ports as active or passive, one of these two commands will possibly make your two ports get bundled or aggregated in port channel number 10. Question number 8, what are two requirements for an HSRP group? An active router, yes, and it will be one active router. You cannot have more than an active router in HSRP. One or more standby routers, no, we can have only one active router and one passive router only in the HSRP and VRRP topology. So I'm sorry, not more than a standby router. One or more backup, the term backup is not used with HSRP. This is for a VRRP protocol. No, even the concept is incorrect. Exactly one standby router, yes, that would be correct, which will be this one, and one backup router, this is also for VRRP. So A and D are the only choices that I can choose in my exam or in my technical what do we call it? It was not a review, not an appointment, I forgot about that. When you go to for a job application, I forgot the English word entirely. I'm sorry, maybe you know that. When you go to meet the manager for the first time in a job, what was the word? This is unbelievable. Sometimes I really forget words. Okay. What occurs to frames during the process of frame flooding? When a switch receives a broadcast message for an unknown destination and it flooded everywhere except the one that sent it. Frames are sent to all ports, including those that are assigned to other VLANs. No, you do divide your switch to multiple VLANs, so if one of the VLANs had a problem, it will be its own problem. Other VLANs will not be included or have a role in that problem. No, frames are sent to every port on the switch that has a matching entry in MAC address table. If it had a matching entry, why would a flooding happen? No. C, frames are sent to every port on the switch in the same VLAN except from the originating port. I will give 3 corrects for this one. D, frames are sent to every port on the switch in the same VLAN. Correct, but it stops here and it does not complete the correct sentence of except from the originating port. This is the tricky thing about flooding. You must know that. Okay, question 10. Almost half of this video is done right now. If all OSPF routers are in a single area and configured with the same priority value, what value does the router use for the OSPF router ID in the absence of a loopback interface? It seems that there is an annoying switch between the routers, so a DR must be elected, and thus also a BDR must be elected as well. Those are details of chapter 3, routing. The question is, what will be the criteria to elect or to assign a router ID for every router? Well, since all the priorities are equaled, and since there is no loopback interface, then we will have to go to option 3, because option 1 is the highest router priority, all are the same. Option 2, the biggest IP address or the highest IP address of a loopback interface, no loopback interfaces here. Option number 3, the highest IP address of a physical configured interface. So the IP address of the first Ethernet, no. The IP address of the console management, don't make jokes. The highest IP address among its active interfaces, yes. The lowest, no lowest there. The priorities are the same. No, priorities are the same already, so it will only be C, and there was a deep dive about that in chapter 3. Which IPv6 block forwards packets to multicast address? This is not blocking, I'm sorry, address block. I'm sorry, I did spell that incorrectly. Which IPv6 address block, a package of addresses, forwards packet to multicast address? Means the IPv6 multicast block. Not the global, not the local, not the link local, but it will be the FF00. That will be D. 12. The OSPF hello protocol performs which of the following tasks? Tricky. A. Negotiates correctness parameters between neighboring interfaces. No. It broadcasts. No. No, it's a it's no. It's not a. The OSPF hello message is a unicast message, I believe. No, 1 minute. What was the multicast doing? No, it's a multicast message. I'm sorry, it's a multicast message. It does not broadcast anything. It provides dynamic neighbor discovery. Yes, this is why it's there already. It detects unreachable neighbors. Yes, correct. In 90-second intervals. No. Your router will send a multicast hello message to the other router every 10 seconds. The first hello will be in the first 10 seconds. The second hello will be in the other 10 seconds. The third, the fourth. After the fourth hello message and still no response from the other guy, this fourth hello message will declare a dead interval. Okay, so the hello interval is 10 seconds. The dead intervals is 4 times the hello message, or the hello interval, which is 4 multiplied by 10, 40 seconds. So after 40 seconds, it will declare or detect some unreachable neighbor. So no, it's not in 90, it's in 40 seconds. It uses timers to elect the router with the fastest links as the designated router, not you, of course. It maintains neighbor relationship, just like D. So yes, F is more correct than D. So C and F are the only correct questions regarding the hello message of OSPF. What are 2 benefits of using a VTP on a switching environment? Why would I use VTP? Let's see. It allows switches to read frame tags. Switches do already read frame tags. What is wrong with you? It allows ports to be assigned to VLANs automatically. No, not at all. You will use VTP to flood VLANs informations to the VLAN tables of all the switches in your network, but you'll have to log in later to every single switch in the network and assign physical interfaces as an access ports to those VLANs. So B is also incorrect, and we wish if B was correct in VTP, then it would be very useful, but it's not. C maintains VLAN consistency across a switch network. Yes, because your switches will always be updated with the latest VLANs added and removed from the network, so C will be correct. It allows frames from multiple VLANs to use a single interface. This is trunking thing, not a VTP. A DTP, it allows VLAN information to be automatically propagated throughout the switching environment, and this is what VTP is all about. VLAN's informations, you will add them by yourself manually to a master switch or a VTP server switch, and it will automatically be propagated to the entire switches in the network, so that all of them will know about the new VLANs and welcome them to their VLAN table. 14. Which purpose does the northbound API? We have 2 types of APIs. Northbound, that connects your controller to the application that you use as a GUI applications to manage your entire network, and the southbound applications back in chapter 7 to connect the same controller downwards to the nodes, to the real devices, routers, switches, access points, controllers, firewalls, etc. So what does a northbound does? Communicates between the controller and the physical network. This is a southbound thing. Reports devices errors to a controller, so the devices to the controller. This is also will be a southbound thing to do. Generate statistics for network hardware and traffic. Maybe because those informations will be propagated and shown to the GUI. So this is kind of correct. Or facilitates communication between the controller and the applications, much more specific. So D is much more correct than I would choose C. So I will take D because D is the idea of northbound APIs and the categorization of northbound APIs, that they live between the management application and the controller. 15. The OSPF Hello protocol performs which of the following tasks? This is duplicated because it provides dynamic neighbor discovery and maintains membership. Leave this one. This is duplicated. I should remove that. 16. What are two reasons a network admin would use Cisco Discovery Protocol? Because it's awesome. But sometimes from perspective of security you need to disable that. So A, to verify the type of cable interconnecting two devices. It will not give you layer 1 informations. It's about layer 2 informations and above. Layer 2 and layer 3 only, actually. To determine the status of network services on a remote device. Network services, you mean like layer 3 and layer 4 up to applications? No. To obtain VLAN information from directly connected switches. I think there depend on the software and the platform of your device. Some VLAN informations might be propagated, but this is very rare or incorrect. Let me leave that for a minute. To verify layer 2 connectivity between two devices when layer 3 fails. So maybe if you cannot reach a device and you are suspecting that maybe the device is down or the cable is broken, just show CDP neighbors details, or show CDP neighbor interface gigabit ethernet 00 detail will show you that the other side, which has the platform of Cisco Catalyst 3560, is up and running, and it's connected to you through its gigabit ethernet 010 to your gigabit ethernet 00 on your side. So it's connected, even though you cannot reach it, but it's connected, it's live, it's not down. To obtain the IP address of a connected device in order to telnet it. Yes, I have been doing that for years. This is extremely correct. But this will show only by using the command show CDP neighbor details. The details will give you a ton of information, correct, like comparing to the show CDP neighbor command. To determine the status of the routing, no, leave layer 3 alone, please. Okay, it will only give you IP addresses from layer 3, but no services, no protocols, not at all. Okay, 17. Refer to the exhibit, and the exhibit is interface gigabit Ethernet, switch port, voice. I hate voice. VLAN 50. An admin is tasked with configuring a voice VLAN. I can see that. What is the expected outcome when a Cisco phone is connected to that interface? So I have a switch. I have this port, which is gigabit Ethernet 314. It is connected to a Cisco IP phone. Okay. This way. Okay, so this way. If you have never worked with an IP phone from Cisco, then take that IP phone, flip it to the back, and see the back side. You will find always, I think, like 80% of the devices, of these devices, you'll find two Ethernet ports on the back. One of them comes from the switch, the other one goes to the end device, to the PC of yours. Why? To avoid extending two long cables from the switch to your two devices, so that you would operate those two devices. Maybe you're an employee, you use your computer, and you will also need an IP phone to communicate with your colleagues, manager, team leader, other departments, and so on. Especially if you're working as a call center agent in a company, in a technical support department, just like I was. Okay, so you will use that for 8 hours a day, like this way, or you'll connect your earphone. But the idea will be to avoid extending two cables from the switch. To make it something more suitable from a design perspective, you will extend only one to the IP phone, and the other one will go to your end device. What happened is that this switch was accessed to VLAN 50 voice VLAN. Every port can carry or encapsulate two VLANs at the same time, a data VLAN and the voice VLAN. So only voice VLAN was shown here. What will happen will that PC operate? It will operate by using the default VLAN that is already passing through this way, this cable. So the phone and the workstation do not have VLAN connectivity. They will have. The phone sends and receives data in VLAN 50, but the workstation connected to the phone sends and receives in VLAN 1. Yes, the phone sends and receives in VLAN 50, but the workstation has no VLAN. It has no VLAN assigned, but there is a default VLAN. Thanks for Cisco. The phone and the workstation connect. Both of them will use VLAN 50. No, because voice VLAN is 50, not data VLAN. So that will be B. Okay. 18, we are almost done today. Okay, that should be enough. An engineer deploys a topology in which R1, this is R1, obtains its IP configuration from a DHCP. So that means that this interface has the command of IP address DHCP, so that it will send a broadcast message all the way to the server. But there is a layer 3 device in the way. So your broadcast message will stop here, and according to chapter 4 that we have studied, by using DHCP relay, you will forward the broadcast message from this interface to this interface. So we will need to enable IPDHCP on this interface and IPDHCP relay on this one. So what happened is that how we will accomplish that. Okay, choose two commands. A, interface fast Ethernet 00 on R1 IP helper address, which is DHCP relay, correct, for this application. For this IP address. This is enabling a relay on R1. No, relay should be here. You are wrong. R2, which is this one, should enable relay. IP helper address on gigabit Ethernet 00 to 100. Correct. Thank you. R1 IP at DHCP. Yes, on fast Ethernet 00. We are done. And no shutdown. R2 enabling DHCP on R2, this is incorrect, and enabling helper address on R1 is also incorrect. Just in case you have seen the entire series, then you will be more than certain about how to answer such question in the exam without blinking. Okay, question 19. What commands are needed to add a subinterface to Ethernet 00? So this is Ethernet 00. It seems that the guy is using a router on a stick, so it will enable two subinterfaces to allow for VLAN 50. I'm sorry, two subinterfaces or only one? To allow for VLAN 50 with the IP address of this one. So also, just in case you have watched the series, then there is a complete lab in the end of the series called CCNA Plus Mega Lab 1, which is how to create subinterfaces, tag the subinterfaces and encapsulate it with a certain VLAN, and make that subinterface a gateway for that specific VLAN, which is in this case 20. So we will have to make the tag of 20. Okay, so we need to search for interface Ethernet 00. This is configuring the global interface, not creating a subinterface. I'm sorry, Ethernet 00.20, correct. The encapsulation is for VLAN 20, correct, and the IP address is the same IP address that is mentioned here. This is extremely correct. C is talking about IP address without encapsulation. It will not operate. Once you hit enter with that line, it will give you an error. The subinterface is not encapsulated. And D, Ethernet 00, also an IP address for the global interface, will be useless because we need to add a subinterface. So only B is correct for this question. The last question for today. I hope that I did not give you a big headache, because so far I believe from 20 questions, maybe 18 or 19 are already mentioned, like in the course that we have studied. So thanks for Cisco for giving questions like, or discussing real technical good questions that will be very useful in the real environments, and also all of them are from the blueprints of the exam. Hosts on the same VLAN can communicate with each other, good, but they are unable to communicate with hosts on different VLANs because there is no layer 3 device. So you'll need either a router with a router on a stick protocol or multi-layer switch with SVI. So you need a router with sub-interfaces configured on the physical interface that is connected. Yes, this is a router on a stick method, and there is a big 90-minute lab in the series about that. A router with an IP address on the physical interface is needed. No. A switch, you see, I'm sorry, go back to the topology of question 19, will be the answer to your question entirely. Okay. See, a switch with an access link that is configured between the switches will do nothing. A switch with a trunk link will also not allow for multiple VLANs to communicate, because there will always be a tag separation. So we will need a layer 3 device to route between different virtual broadcast domains. This is the end of today. That is good. I hope that everything was clear for you, and there will always be a comment area below this video to discuss everything that you might have and concern in your mind, and after that we'll go to the next video of another 20 questions. Thanks again, and hope to see you in the upcoming video. Goodbye.